नमस्कार. रयत ऑनलाईन स्कूल एज्युकेशन ज्युनियर कॉलेज या प्रकल्पामध्ये पुन्हा एकदा आपणा सर्वांचं स्वागत. आजचा टॉपिक 12वी साठी आहे सब्जेक्ट फिजिक्स. नेम ऑफ द युनिट इज मेकॅनिकल प्रॉपर्टीज ऑफ द फ्लुइड्स and the sub point is 2.4.7, that is capillary action. Presentation made by Mr. P.M. Shinde, Junior College Teacher, कर्मवीर भाऊराव पाटील विद्यालया and Junior College, Boyens. Now what is the capillary action? For this we must know what is capillary. A glass tube having very fine bore, it is in the order of 1 millimeter and open at both ends, is called as the capillary. In this picture we can see the capillary. Here is a glass tube. It is open at both ends. There is another glass tube and there is a bore which is in the order of 1 millimeter diameter. This is the capillary. What is the capillary action? In case of the liquid which partially or totally wets the capillary, liquid rises inside the capillary. This property is seen in case of the liquid which partially or totally wets the capillary. In case of the liquid which does not wets the capillary, the liquid level falls inside the capillary. Now we will consider a liquid like a water. In this beaker there is a water and a capillary is dipped in that water. What will happen? The water will enter in the capillary and it moves to certain height than the horizontal level in the beaker. This is the capillarity. A liquid which partially or totally wets the capillary, the liquid rises. Water is a liquid which totally wets the capillary, therefore the liquid level inside the capillary rises. A liquid level inside the capillary, it will fall when the liquid does not wet the capillary. There is an example of the mercury, which is the metal, but it is in liquid form. When mercury is taken in the beaker and capillary is dipped in the mercury, we can see the mercury level, it falls inside the capillary than the horizontal level in the beaker. This is the capillary action. The applications of the capillarity, these are as follows. A sap or a water rises up to the topmost leaves in the tree. Water rises up the crevices in rocks. Cloth rug soaks the water. Blotting paper absorbs the ink. Ink rises in a pen. Oil rises up the wick of the lamp. Now here are some pictures. In this picture we can see how the capillary action takes place. Where the capillary action takes place. या ठिकाणी झाडांची काही चित्र दिसत आहेत बघा. इथं नारळाचं झाड दिसतंय. या नारळाच्या झाडाच्या अगदी टोकापर्यंत, पानांच्या अगदी टोकापर्यंत पाणी हे चढत असतं बिकॉज ऑफ द कॅपिलॅरिटी ऍक्शन. या ठिकाणी झाडाचा बुंदा आहे, त्या बुंद्याला थोडंसं छिद्र पाडलंय बघा या ठिकाणी. त्याच्यातून पण आपल्याला लिक्विड खाली ड्रॉप होताना दिसत. हे पाणी कुठून आलं तर हे पाणी येतं मुळांच्या पासून आणि ते झाडांच्या खोडातून वर चढत असतं. हे पाणी वर चढण्याचं कारण म्हणजेच कॅपिलरी ऍक्शन. वॉटर रायझेस अप द क्रिव्हायसिस इन रॉक्स. या ठिकाणी पाण्याचा जो प्रवाह असतो त्याच्या शेजारचे जे खडक आहेत त्या खडकांच्या भेगामधून पाणी वरती चढत असतं. हे सुद्धा आपल्याला बघायला मिळतं. दिस इज द वन ऑफ द बेस्ट एक्झाम्पल ऑफ द कॅपिलरी. क्लॉथ सोक्स द वॉटर. नेहमी आपण वस्तू पुसण्यासाठी, फरशी पुसण्यासाठी अशा पद्धतीचे क्लॉथ्स वापरत असतो. ते पाणी शोषून घेतात, त्याचं कारण कॅपिलरी. ब्लॉटिंग पेपर ॲब्सॉर्ब्स द इंक. ब्लॉटिंग पेपर हा इंक शोषून घेण्याचं काम करत असतो. ते सुद्धा या ठिकाणी आपल्याला दिसतं. इंक रायझेस इन अ पेन. या ठिकाणी इंकचा एक ड्रॉप पडलेला दिसतो. इथं फाउंटन पेन आहे, तर त्या पेन मध्ये ही इंक वर चढलेली सुद्धा आपल्याला बघायला मिळते. इट इज बिकॉज ऑफ द कॅपिलरी ऍक्शन. अजून एक सगळ्यात चांगलं एक्झाम्पल म्हणजे या ठिकाणी लॅम्प दिसतोय आपल्याला. पंती आहे, पंतीमध्ये तेल आहे, त्याच्यामध्ये वात टाकलेली आहे आणि या तेलाच्या साह्याने ही वात ही पेटत राहते. तेल या वातीतून वर येत राहतं. दिस इज also capillarity. Now explanation of the capillarity. Initially we will explain first the capillary fall. Mercury is the liquid which does not wet the solid, which does not wet the capillary. Hence the liquid level inside the capillary falls. The shape of the surface of the mercury in the capillary is convex. We can see here a convex surface. Here is the diagram which show the capillary fall. Consider there is a liquid in the container. The liquid is the mercury. The capillary is dipped in the mercury. We will consider points A, B, C and D. These are the 4 different points as shown in the figure. Inside the capillary, A is the point which is just above the curved surface, and B is the point just below the curved surface. Outside the capillary, C is just above the plane surface and D is the point just below the plane surface. या ठिकाणी आपल्याला हे दोन पॉइंट दिसत आहेत. हे कॅपिलरी मधले आहेत, हे आउटसाइड द कॅपिलरी कंटेनर मधले पॉइंट्स आपल्याला दिसत आहेत. या प्रत्येक पॉइंटच्या ठिकाणचं प्रेशर आपण या पद्धतीने समजून घेऊ. PA is the pressure at point A. Similarly, PB, PC, PD, these are the pressures at point B, C and D respectively. We know that the pressure on the concave side of the surface is greater than the pressure on the convex side of the surface of the liquid. Concave part ला pressure जास्त असतं. Mathematically कसं सांगता येईल, तर PB is greater than PA. या PB जवळचं प्रेशर हा कॉन्केव्ह पार्ट असल्यामुळं PB जवळचं B पॉइंट जवळचं प्रेशर which is called as PB, it is greater than PA. The pressure is same on the two sides of the plane surface. At the same time, C आणि D पॉइंट जे आहेत या ठिकाणचं प्रेशर सेम असणार आहेत, म्हणजेच PC equal to PC. The point A and C, in this diagram we can see the point A and C, they are at the same horizontal level in the air. The pressure at these 2 points is equal to the atmospheric pressure. A आणि C पॉइंट जवळच्या प्रेशरला आपण atmospheric pressure म्हणू शकतो. Therefore we can write PA is equal to PC is equal to atmospheric pressure. This is the equation number 3. This is equation 1, 2 and 3 are there. From the equation 2 and 3 we can write हे 2 आणि 3 नंबरचे इक्वेशन बघा. PC equal to PD and PC equal to PA. PC हे PD बरोबर पण आहे आणि PC PA बरोबर आहे, म्हणून PA is equal to PD असं आपल्याला म्हणता येईल. म्हणजे प्रेशर ॲट पॉइंट A is equal to pressure at point D. Therefore we can write PB is greater than PD. PB आणि PD मध्ये हे PB सगळ्यात मोठा असेल. PB is greater than PD. Means in the liquid there are 2 points. B is inside the capillary and D is outside the capillary. And these 2 points, they are at different pressures. At the point P, the pressure is greater than the point D. Then what will happen? There will be flow of the liquid from capillary to the outer side. Now in this diagram we can see the liquid level, it falls inside the capillary because of the pressure difference between the point B and D, and this fall will continue till the point B and D, they are at equal pressure. Means up to the equilibrium the liquid flows from capillary to the outside, and in this way there is a fall of liquid inside the capillary tube. In this way we can understand why the liquid falls when the capillary is dipped in the liquid which does not wet the solid. Similarly, we can understand the capillary rise also. In this diagram we see a container. In the container there is a water, and in the water Again there is a same capillary is dipped. What will happen? As soon as the capillary is dipped in the water level rises inside the capillary tube than the horizontal level in the beaker. This is the capillary rise. The shape of the surface of the water in the capillary is now concave. या ठिकाणी आपण कॉन्केव्ह सरफेस दिसतोय बघा. वॉटर असेल, कॅपिलरी ट्यूब असेल तर त्या ठिकाणी कॅपिलरी मधली राईज आहे त्या ठिकाणी कॉन्केव्ह सरफेस आपल्याला बघायला मिळतो. अगेन वी विल कन्सिडर 4 पॉइंट्स A and B. These are the point inside the capillary, and C and D, these are the points outside the capillary. A is just above the curved surface and B is below the curved surface, but it is inside the capillary. C is the point just above the plane surface and D is the point just below the plane surface but outside the capillary. The pressures will be PA, PB, PC and PD at the points A, B, C and D respectively. The pressure on the concave side of the surface is greater than the pressure on the convex side of the surface of the liquid. Concave बाजूला pressure जास्त असतं. Therefore we can write again PA is greater than PB. This is the equation number 1. PA is greater than PB. A point जवळचं pressure जास्त आहे. The pressure is same on the two sides of the plane surface. C आणि D point ला pressure same असणार आहे. Therefore we can write PC is equal to PD. The points A and C are at the same horizontal level in the air. The pressure at these 2 points is equal to the atmospheric pressure. Therefore we can write PA is equal to PC and it is nothing but the atmospheric pressure. This is the equation number 3. Now we will consider the equation 2 and 3. Which are these equations? PC equal to PD and PA equal to PC. Therefore we can write PA equal to PD. PA आणि PD या ठिकाणचं प्रेशर सेम असणार आहे. A point आणि D point जवळचं प्रेशर सेम असणार. From the equation 1 and 4 we can write PD is greater than PB. D point जवळचं प्रेशर जास्त आहे आणि B point जवळचं प्रेशर कमी आहे. B हा पॉइंट इनसाइड द कॅपिलरी ट्यूब आहे. D हा आउटसाइड द कॅपिलरी ट्यूब आहे. What will happen? Since there is a pressure difference at the point B and D, there will be flow of the liquid from higher pressure to the lower pressure, and therefore the liquid rises in the capillary tube because there is a flow of a liquid from point D to point B, that is from outside the capillary tube to the inside region of the capillary tube, and therefore the liquid level inside the capillary tube rises. This rise in the liquid level, it will continue till the equilibrium, that is up to the same pressure level for the point B and point D. When these 2 points they attain the same pressure level, the flow of the liquid stops and we will get this rise in the liquid level when a capillary is dipped in a liquid which partially or totally wets the solid.